Hello friends, welcome to the another session. Today we are discussing the Joule's Thomson's porous plug experiment. Before going to start the Joule Thomson's porous plug experiment, we know about the Joule's experiment. So Joule performed an experiment to study the intermolecular attraction between the molecules of a gas. He designed an apparatus to measure the change in energy of a gas when its pressure and volume are changed. Here are the two flasks. That is, the smaller flask is having high pressure gas and the larger flask is having vacuum or perfectly evacuated. So these two flasks is connected with the small tube having a stopcock. So here now I am referring high pressure gas flask is referred as A, while this flask which is evacuated is B. A was filled with a gas at a high pressure and B was perfectly evacuated. The bulbs were surrounded by a water bath and its temperature was noted with sensitive thermometer. The stopcock was opened and the gas rushed from A to B. So this is the green line showing the gas is rushing from A to B in evacuated flask. So if work was done during the expansion, what we expect? We expect the cooling is, but in this experiment no cooling was observed. This was puzzling as the work had been done by the gas in overcoming the forces of intermolecular attractions. Joule was able to explain the drawback in his experiment by assuming that the gas expanded into vacuum and so on, cooling was observed. So there is no cooling observed. In this experiment, only the pressure and volume of the gas changed, and as the bath did not show any change in temperature, it is evident that the temperature of the gas remained constant. So according to Joule, this experiment also shows that the internal energy of the gas is a function of temperature only, irrespective of the changes in pressure and volume. Thus, so long as the temperature of the gas remains constant, its internal energy, that is the U, remains unchanged. This experimental result is often referred as Joule's law and may be stated that the internal energy U of a gas depends only on its temperature T and is quite independent of its volume V and pressure P. Mathematically, internal energy U is the function of T. The U is equal to F of T. So we get change in internal energy by change in volume at constant T is equal to 0. And similarly, change in internal energy with divided by change in pressure at constant T is equal to 0, and we get, so du by dt at constant P is equal to du by dt at constant V. So the first du by dV and du by dP is equal to 0 implies that the internal energy of the system does not change with volume or pressure as long as the temperature remains constant. And this equation indicates that the increase of internal energy per degree temperature of, or the per degree temperature is the same no matter whether the pressure or the volume is kept constant during the process. It should be noted that the Joule's law is obeyed strictly by a perfect gas only. The porous plug experiment designed by Joule and Kelvin, however, showed cooling due to the cooling due to the work done by the gas in overcoming the intermolecular attraction when it was passed from the high pressure to the low pressure side. So this is the Joule's experiment. If a gas, what is the effect of the Joule-Thomson effect? If a gas initially at a constant high pressure is allowed to suffer through a throttle, expansion through the porous plug of silk wool or cotton wool having number of fine pores to a region of constant lower pressure, adiabatically a change of temperature of the gas, that is either cooling or heating, is observed. This effect is called as Joule-Thomson's or Joule-Kelvin effect. Joule, in collaboration with the William Thomsons, devised a very sensitive technique known as a porous plug experiment and performed number of experiments from 1852 to 1862 and established beyond doubt the existence of intermolecular attraction. In this effect, the total heat function H is equal to U plus PV, that is remains constant. At ordinary temperature, all gases except hydrogen shows cooling effect on passing through the porous plug, but hydrogen shows a heating effect. At sufficiently low temperature, all gases shows a cooling effect. So we discuss about the Joule-Thomson porous experiment. So this is the Joule-Thomson effect. Now actually we are performing the experiment. What is the theory and what is the action of the experiment will be discussed. The experimental setup for the porous plug experiment to study the Joule-Thomson effect. It consists of the apparatus with the porous plug having two perforated brass disc, here this side D, referred as a D. The space between DD is packed with the cotton, wool or silk fibers. So this white dashed line is referred, or area is filled up with the cotton wool or silk fiber. The porous plug fitted in a cylindrical box wood, that is the W, which is surrounded by a vessel containing a cotton wool. Why the cotton wool is surrounded to this wooden, what we say, the cylindrical box? to avoid loss or gain of heat from the surroundings by filling the cotton wool or silk fiber. So there is no loss of energy, heat, or loss of gain of heat. Then the two temperatures are there, T1 and T2. Here it is when the gas is entering this side. So first T1 is there. When the gas escapes, then the temperature from the porous plug, then the temperature T2 will be measured. And the two sensitive platinum resistance thermometer is there, and they measure the temperature of the incoming and outgoing gas. Now the gas is compressed to a high pressure with the help of piston, and it is passed through a spiral tube. That spiral tube is fitted in a water bath. Water bath maintained at a constant temperature. If there is any heating of the gas due to the compression, this heat is absorbed by the circulating water in the water bath. And here it is the pressure gauge to measure the pressure of gas. So this is the setup of Thomson's porous plug experiment. Now what is the experimental procedure? अब हम क्या करते हैं यहाँ पे कि by compression of the piston P क्या होगा? The experimental gas is passed slowly and uniformly through the porous plug, and keeping the pressure, that is the high pressure, that pressure is measured by the pressure gauge, and that high pressure remains constant, and that will be read by the pressure gauge. During it passes through the porous plug, the gas is throttled. Why it is throttled? That is, the operation between the molecule increases. On passing through the porous plug, the volume of the gas increases against the atmosphere pressure. As there is no loss or gain of heat during the whole process, the expansion of the gas takes place adiabatically. The initial and final temperatures are noted by means of platinum resistance thermometer T1 and T2. So this is the experimental procedure. What is the result of that? Why we perform this experiment? The behavior of gas, that gas contains the large number of molecules. So we can study the behavior of the large number of gases was studied at various inlet temperature of the gas, and the results observed, like at a sufficiently low temperature, all gases shows a cooling effect. At ordinary temperature, all gases except hydrogen and helium showing cooling effect. Hydrogen and helium shows heating instead of cooling at a room temperature. Next, the fall in temperature is directly proportional to the difference in pressure on the two sides of the porous plug. Fourth, the fall in temperature for a given difference of a pressure decreases with rise in the initial temperature of the gas. It was found that the cooling effect decreased with the increase of initial temperature and becomes zero. At a certain temperature and at a temperature higher than this temperature, instead of cooling, heating was observed. This particular temperature at which the Joule-Thomson effect changes the sign is called the temperature of inversion. Means the temperature at which Joule-Thomson effect is zero and changes the sign is known as the temperature of inversion, and it is denoted by Ti. And at this temperature we can write the equation 2A by RTI is equal to B. So Ti is equal to 2A by RB. When T is greater than Ti, heating takes place. T is less than Ti, cooling takes place. For helium, the temperature of inversion is 35 Kelvin, and for hydrogen, the temperature of inversion temperature is 193 Kelvin. So this is the Joule-Thomson's porous plug experiment. In next session, we discuss the Joule-Kelvin effect, temperature of inversion. So, or you can simply say that Joule-Kelvin effect or temperature of inversion. So, by the experiment we get, if the gas is at the temperature of inversion, then no cooling or heating is observed when it is passed through the porous plug. If the gas is at a high temperature or at a temperature lower than the temperature of inversion, cooling will take place. When it is passed through the porous plug, this is called the regenerative cooling or simply Joule-Kelvin cooling. This principle has been used in the liquefaction of the so-called permanent gases like nitrogen, oxygen, hydrogen and helium. If the gas is at a temperature higher than the temperature of inversion, instead of cooling or heating is observed when the gas is passed through the porous plug. So this is the Joule-Thomson's experiment. In next session we discuss the temperature of inversion and relation between the temperature of inversion and Boyle's temperature. So thank you very much for watching this video.